In the last episode, our mechanical designer Keith talked about the new transfer mechanism that will redefine the traditional cryosample transfer workflow, where there is always a significant risk of sample damage. In this episode, we invited our application specialist Casper to introduce how we can ensure the cryosample actively stays cooled with a microcooler. Let's get right into the interview.
Hi, my name is Casper Jonker. I'm an application specialist here at Delmic. I'm also a cell biologist, and I've used many different types of light and electron microscopes over the years during my postgraduate and postdoctoral research. And I'm now using this knowledge to help design and test systems here at Delmic. One of the projects I'm working on is ENSEL, which you can see here. It's our inverted light microscope that can be integrated into a dual beam SEM system, and it's designed to improve the workflow of the cryo-electron tomography sample preparation. In previous videos, my colleagues have explained different aspects of the ENSEL system, and today I will explain one more, and that is the cryocooler. For cryo-electron tomography, the sample needs to remain vitrified, meaning that we have to keep the sample below 135 Kelvin or around minus 137 degrees Celsius. To keep the sample as stable as possible, actually lower temperatures are even preferred. This means that the sample needs to be actively cooled, and this is done with the cryostage. On a regular cryostage, the sample sits on a solid platform that is cooled with cold nitrogen gas. This is not the best option for ENSEL, because with ENSEL, the objective lens approaches the sample from below. Having the objective below the sample allows us uniquely to image the sample above with the SEM, from the side with the ion beam, and from below with the light microscope. However, this inhibits us from using a solid platform as a stage. This is why we developed a unique microcooler that allows still the sample to be approached from below and can also actively cool the sample and can also move and tilt the sample in any direction that is needed for the cryo-electron tomography workflow. The cooler has an arm with the sample holder at the tip. The sample holder holds the sample over the objective, which sits on the objective stage. The cooler body itself sits on the sample stage, which allows the sample to be moved in all directions that are needed for the cryo-electron tomography workflow. The tip itself is actively cooled using nitrogen gas using the Joule-Thomson effect. This is the same process that is used in refrigerators. Except with this cooler, we can keep the sample stable at 108 Kelvin or minus 165 degrees Celsius while it's being processed. As you can see, this unique cooler design solves the issue of having a sample that needs to be cooled but still needs to be able to be approached from all imaging directions. There are many more clever solutions here at Delmic that we integrate in our systems, and if you want to know more about them, you can keep an eye out for our following episodes.